Audio lecture, The Scientific Revolution. The Scientific Revolution. First, let's talk about how it is different from the medieval view of the world. The medieval view of the world was primarily religious and theological. It was political theory that was based on the divine right of kings was part of that as well. It incorporated the same ideas. And society is governed by church views, traditions, and practices. Superstition played a major role in the way things were done in the medieval times. The scientific thought in the early 16th century was still based on medieval ideas. Views about the universe were largely influenced by the ancient ideas of Aristotle during the Renaissance. The geocentric view held that the Earth was at the center of a static, motionless universe. Science was essentially a branch of theology. Now, causes of the scientific revolution. Medieval universities really is where it starts. By 1300, philosophy had become an accepted discipline. Medieval philosophers developed a degree of independence from theologians and a sense of free inquiry. Leading universities also established new professorships of mathematics, astronomy, and physics within their departments of philosophy. And this is all going to eventually give way to an exchange of ideas that will help to bolster scientific thought into a new way of thinking about things. Major scientific figures either studied or taught at universities. The Renaissance stimulated science by rediscovering ancient mathematics. Again, the Renaissance as a starting point for this whole entire course. The Renaissance patronage was often scientific as well as artistic and humanistic as well. Navigational problems on sea voyages in the age of overseas expansion created a need for more scientific advances. New instruments like the telescope, barometer, thermometer, pendulum, clock, microscope, and air pump also aided in this. Gresham College in England was a place where scientists worked closely with top officials in the Royal Navy that were doing the explorations and leading merchants and shipbuilders who were also participating in the explorations. It became the main center of scientific activity during the first half of the 17th century as a result. Gresham College, England. Scientific methodology, meaning the way they thought about things, develops. Bacon, Francis Bacon formalized empirical and experimental research. Descartes emphasized deductive reasoning. We'll talk about both of these in more detail as we go through this lecture. The scientific revolution became the major cause of the new worldview that developed in the 16th and 17th centuries. Secularism emerged, as we saw with the Renaissance, and many educated people became openly hostile towards religion, or at least closed-mindedness in some religious sectors. The revolution in learning became a major foundation in Western society as a result. We're going to start with astronomy in the 16th century. Nicholas Copernicus is probably considered sort of the grandfather of the scientific revolution. He wrote a book called On the Revolutions of Heavenly Spheres. It was actually published the same year that he died. He held off on publishing it while he was living because he was worried about backlash from the scientific community as well as from the church. He dedicated the book to Pope Paul III and did not intend for his theories to challenge church doctrine in the first place. However, the church will find much of what he theorized distasteful. Here's an illustration published in his book showing the sun at the center of the universe. challenging the geocentric or earth-centered notion of the universe. The heliocentric view, he argued, made more sense. It put the earth revolving around the sun and the sun as the center of the universe. He observed that stars did not move, although the apparent movement of the stars, in fact, was the result of the Earth's rotation. Again, it's a very humanistic thing that he did. He looked to the source himself, the skies, the heavens, and to look for answers. The universe now seemed enormous, perhaps infinite. A major anomaly, however, in his theory was retrograde motion of planets relative to the Earth's position. This was remedied by the false premise of epicycles. This is something that will be dealt with by later thinkers. You see, Copernicus had a theory of the heliocentric view, but he didn't really have the math to prove it. That will be left to others who follow in his footsteps. So we see the scientific revolution as building blocks as such. Copernicus' ideas directly challenged Ptolemy's 2nd century AD view of a geocentric universe. This was the concept of the universe that the Roman Catholic Church had adopted as their principal idea of, how the universe was arranged. So heliocentrism seemed to challenge the Bible's book of Genesis that put forth a geocentric view. God created the earth with man in the center of it, with the earth at the center of his universe, of his creation. Religious reaction to the Copernican theory. Martin Luther and John Calvin, both, even though they were humanists themselves, both of them condemned Copernicus' theory. They pointed to biblical passages supporting what they saw as the medieval view of geocentrism, an earth-centered universe. The Catholic reaction actually was initially less forceful, as the church didn't always interpret the Bible literally at that point in time. However, with later popes, they will. Yet, by 1616, about a generation later, the Catholic Church had proclaimed the Copernican theory as false and persecuted those who advanced those views. The example would be Galileo. So Galileo, a generation later, was doing his theorizing and his experiments when there was a stronger, more forceful pope who rejected the ideas of heliocentrism officially. Tycho Brahe ultimately was Europe's best astronomer in the late 16th century. He built the best observatory in Europe, and for decades he collected massive amounts of data on his observations of the cosmos. This data became a cornerstone of astronomy for centuries. He collected much of the data, even though he himself did not theorize much about what he collected. He left that to others. His data later will help to prove Copernicus' theory of the heliocentric universe. Ironically, he himself did not even accept the Copernican view, but his data will prove it. Brahe's quadrant was among the largest of his era and allowed him to make minute measurements of the cosmos. The King of Denmark gave him the island on which his observatory was located. It was the island of Haveen to use for his observatory. It was completely his to do with as he wished. Johann Kepler is the next great scientist. As a matter of fact, he was the first great Protestant scientist who earlier had worked as an assistant to Brahe. He is the one that will take the data that Brahe collects, and he will make something of it by applying the mathematics to prove Copernicus' theory. Mathematically, he will be the one responsible for proving that Copernican heliocentric theory. He also comes up with the concept of the 3 laws of planetary motion. He argued that the orbits of the planets are elliptical, not perfectly round. Planets do not move at uniform speeds while in their orbits either. And the time it takes for a planet to orbit the sun is directly based on its distance from the sun. Kepler's model of the solar system is pictured here, with the sun at the center of the universe. Kepler's edifice of astronomy is located on the frontispiece of his 1623 book, Rudolphine Tables. The 17th century is where we really see the scientific revolution take off. It really begins with Galileo Galilei. He developed or refined the laws of motion, building on the groundwork laid by earlier thinkers, using an experimental method to prove them. He used the experimental method with controlled experiments and observation. He did an acceleration experiment where it was noted that gravity was a universal force that produced uniform acceleration. This was the whole dropping the two rocks that weighed different weights from the top of the Leaning Tower of Pisa, which probably wasn't leaning so much back then, and they fell at uniform rates of acceleration. In other words, all falling objects descend with equal velocity regardless of their weight. The law of inertia was also developed by Galileo. An object that is in motion will remain in motion until it is stopped by some external force. Now, he did not name that force gravity at this point, but we know that that universal force will eventually be defined by Sir Isaac Newton. He validated, however, Galileo validated Copernicus' heliocentric view with the aid of a telescope that he built. Again, humanistic, look to the source yourself for answers. Galileo was the first to use the telescope as a scientific instrument, and like I say, he built one himself. He demonstrated that the moon and other planets were not perfectly round orbs like a crystal sphere, which was the prevailing medieval view. Instead, those ellipses that Kepler had talked about were more accurate. He discovered also the four moons of Jupiter, thus refuting the notion that Jupiter was embedded in an impenetrable crystal sphere. Instead, it orbited on its own volition. Galileo's use of the telescope demonstrated that the moon was not a smooth orb either, as had been previously thought. He found on it, of course, craters. Galileo's findings became controversial in Catholic countries. And of course, since he was Italian, that will be an issue. His views were largely supported in Protestant Northern Europe, where reformers had questioned Catholic doctrines. The Catholic Church, however, in 1616, declared the Copernican theory to be heretical. So that meant that all of Galileo's writings would also be considered heretical, since they supported this Copernican theory. In 1632, Galileo published his dialogue concerning the two chief world systems, in which he wrote about the Copernican system as a mathematical proposition. In 1633, the inquisition of Pope Urban VII forced Galileo to retract his support for the Copernican theory on punishment of death if he did not. Galileo will retract his statements, but he argued his entire life, living under house arrest, that he was always right. And of course he was. He remained under house arrest for the rest of his life in Florence, Italy, where he is buried today. He was discredited in the realm of science, and his writings would be put on the index of prohibited books for years. He is only exonerated in the 20th century, posthumously. Sir Isaac Newton kind of is the one who summarizes or culminates, if you will, the scientific revolution with his thoughts when it comes to astronomy. He integrated the astronomy of Copernicus and Kepler with the physics of Galileo, and he combined all this into an overarching theory on how the universe worked. Again, showing you the building blocks of the scientific revolution. He himself, in his introduction to his Principia Mathematica that you see pictured here, recognized that he, quote, stood on the shoulders of giants. He comes up with the principle of universal gravitation. This, again, is detailed in what is sometimes referred to in English as the mathematical principles of natural philosophy, known more popularly as the Principia Mathematica, or just the Principia. 1687 was when this book would be published, and it's perhaps the greatest book on science ever written. The natural laws of motion, gravitation, are evident in the movement of heavenly bodies and earthly objects. He developed a set of mathematical principles to explain motion. Every body in the universe attracts every other body in the universe in a precise mathematical relationship based on gravity, the gravitational pull between the objects. Since these natural laws are unchangeable and predictable, he believed God's active participation in the natural world was not needed to explain the forces of nature. This directly challenged medieval beliefs about a God that gets actively involved in the universe on a daily basis. This view instead came to be the foundation of the Enlightenment view of God, known as deism. Understand this. He believed that there was a creator God, and God created the universe. He also created the natural laws that govern the universe, and he set the universe in motion according to these natural laws, then stepped back and let it run. There was no need for him to be actively involved, since he set the laws that determine the motion of the universe in motion as well. Newton is also known for inventing calculus. He did this in order to complete his theory and to help to explain it. Although another German mathematician, Leibniz, also claimed to have invented calculus as well. Now, we will talk more specifically about how the ideas of Newton and the natural laws that govern the universe ultimately are applied by the Enlightenment thinkers, taking the same notion: if there are natural laws that govern the universe, then there must be natural laws that govern society. Taking those ideas out of the laboratory, so to speak, and applying them to society. That will eventually become the basis of the Enlightenment. We'll talk more about that in the next lecture. Now we're going to move on to talking about the scientific method. Again, I mentioned Bacon and Descartes before, and now I'm going to explain them in a little more detail. Francis Bacon, 1561 to 1626. He formalized the empirical method, or what is known as empiricism, that had already been used by Brahe and Galileo. He just formalized it into a practice. Ultimately, this is known as the inductive method for scientific experimentation. You begin with inductive observation, then form a hypothesis, then conduct experiments to test that hypothesis, then organize your data. Francis Bacon said that we must renounce notions and begin to form an acquaintance with real things. Bacon's inductive method would be coupled with Descartes' deductive method, or deductive reasoning, and to form the backbone of the modern scientific method. Inductive plus deductive equals the scientific method. Here's the frontispiece of his History of Royal Society of London. Bacon is located on the far right. Now, speaking of Descartes, now let's talk about his ideas of deductive reasoning or deductive method. He wrote a book called Discourse on Method, where he advocated the use of deductive reasoning, sort of the other side of the same coin. Inductive on one side of the scientific method coin and deductive on the other. He employed deductive reasoning to prove his own existence. This is summed up in the Latin phrase cogito ergo sum, or I think, therefore I am. If I can think, therefore I must be. He believed that science must do the following. Start with clear, incontrovertible facts. Then subdivide each problem into as many parts as necessary using a step-by-step logical sequence. He demonstrated the relationship between algebra and geometry and developed what is known as analytical geometry. Cartesian dualism is where it divides up all existence into both the spiritual and the material. The spiritual existence of things can only be examined through deductive reasoning, logic. The material is subject to the inductive reasoning or the experimental method. In other words, the inductive method starts with collecting data and then coming up with a hypothesis, testing the hypothesis, and then reorganizing your data. Whereas deductive reasoning starts with a fact and then tries to prove the fact through breaking it down. Okay, kind of like if you've taken geometry, geometric proofs do that. The modern scientific method, as I said before, takes the inductive method of Bacon plus the deductive method of Descartes. Here's a memory device for the scientific revolution. Cops bring kids great big donuts now. Copernicus, Brahe, Kepler, Galileo, Bacon, Descartes, and Newton. Those are the superstars of the scientific revolution. Anatomy, physiology, and biology. Now let's talk about how the scientific revolution impacted these sciences. Scientists began challenging traditional Greco-Roman medical theories of health and disease, such as the 2nd century Roman physician Galen. Galen believed a proper balance of the 4 humors, which he called blood, phlegm, black bile, and yellow bile, were the basis for human health. And when any of those were out of balance, that was when illnesses happened. Bloodletting was a common method used to try to place those humors back into proper balance. And we know that that doesn't do anything. But that's the way things have been done since the ancient times, since the 2nd century. Come along in the late 15th century, early 16th century, a man named Paracelsus. He was a Swiss physician and alchemist, and he was a pioneer in the experimental method used or applied in medicine. He experimented with the use of various chemicals and drugs to deal with medical issues that he saw as chemical imbalances rather than humoral imbalances. Vesalius wrote a book called The Structure of the Human Body in 1543. He was a Flemish physician, and his book renewed and modernized the study of human anatomy. It included about 200 detailed drawings, of which many he drew himself, but others were drawn by other artists, that ushered in a revolution in the understanding of the human body. He would work closely with great artists to help come up with how the body really worked based on its anatomy. Cutting up bodies, stealing bodies out of graves so he could dissect them, etc. He dissected cadavers, many of whom had been criminals, to achieve stunning detail in his drawings. He was the first to assemble human skeletons as well. Here are some drawings from some of his books. William Harvey is another pioneer in the medical field during this scientific revolution. He was an English royal physician, meaning he was the physician to the royal household. And he wrote a book in 1628, it was published, called On the Circulation of Blood. He's around during the Stuart dynasty. In this, he explained how blood was pumped by the heart and circulated throughout the body via veins and arteries in a circulatory system. Anton van Leeuwenhoek is another medical scientist. He's known as the father of microscopy. He developed very powerful microscopes to look at things that were super, super tiny, too tiny for the human eye to really understand. He was the first to see and write about bacteria, yeast plants, living organisms in a drop of water, and the circulation of blood corpuscles and capillaries. Royal scientific societies were really responsible for advancing the scientific revolution. Governments, especially monarchs in mostly Protestant countries, encouraged scientific inquiry as a means to further the prestige of the state and remain at the cutting edge of technology, especially as some of this technology could help them in the age of exploration as well. You know, celestial navigation is going to help you get to your location more quickly. These royal scientific societies created a means by which scientists could communicate with others internationally and exchange of ideas. And this helped forge an international scientific community. This, of course, would be part of cultural diffusion as well. The Royal Society in England was perhaps the most successful and prestigious, founded in 1660. Others were created in Naples, France under Louis XIV, Prussia under Frederick I, and Russia by Peter the Great. Consequences of the scientific revolution. It will lead directly to the Enlightenment, as I stated before. Also, it led to improvements in exploration, like John Harris's chronometer, which gave mariners the ability to easily determine longitude. Experimentation also helped to accelerate the agricultural revolution in the 18th century that we will talk about in a later unit. Improvements in medical knowledge later led to medical advances in both the 18th and 19th centuries. And also reduced the support for witch hunts by discrediting superstition and witchcraft as fallacies. Science and religion were not in acute conflict with each other, really, until the 18th and 19th centuries, when the scientific revolution became commonplace. There were very few attempts in the 17th and 18th centuries to secularize science. Scientists believed they were studying and analyzing God's creation. The universal agreement existed among scientists and philosophers regarding the supernatural origin of the universe. These earlier scientists did not discount that there was a creator God. The debate instead centered on the extent to which God continued to be involved in his creation. After the Catholic Counter-Reformation, the Church became more hostile to science, and science declined in Italy as a result, but not in France, because under Louis XIV, you see the Church really was a branch of the government led by the king, even the Roman Catholic Church in France. Protestant countries, however, did become the leaders in the scientific revolution, especially England, because the ideas did not seem to directly challenge the doctrines of most of the Protestant faiths by the time we get into the 17th century. Alchemy and astrology. Alchemy and astrology continue to appeal to elites and some natural philosophers, in part because they shared with the new science the notion of a predictable and knowable universe. Alchemy was the medieval forerunner of modern chemistry, as it dealt with the supposed transformation of matter, as in converting base metals into gold, or finding a universal elixir that would restore one's youth. No clear line between alchemy and chemistry existed in the 17th and 18th centuries. Paracelsus mixed magic and valid science in ways that defied modern science as well. Girolamo Cardano was a pioneer of algebra who also studied and subscribed to alchemy. Both Brahe and his protege Kepler believed in alchemy. Brahe even had a laboratory dedicated to its study. The Philosopher's Stone, or the Sorcerer's Stone of Harry Potter, was all about alchemy. That's what Nicholas Flamel was. He was an alchemist. Isaac Newton believed in principles of alchemy as he devised his theory of universal gravitation. He devoted more time, actually, writing about alchemy than to either optics or physics, oddly enough. Astrology. Prominent leaders such as Queen Elizabeth of England paid astrologers to forecast their future. Girolamo Cardano prepared horoscopes for Edward VI of England. Brahe was the court astrologer in Denmark. Kepler was the astrologer to the Austrian Habsburgs, and Galileo provided horoscopes to the Medici. Astrology, however, experienced a decline during and after the Enlightenment in the 18th century. The oral culture of peasants, a belief that the cosmos was governed by divine and demonic forces, persisted, however. Everything in the universe, people, the world, seemed interconnected to the peasants, to the superstitious peasants. Astrology coexisted with religion, magic, and science in their minds. The persistent belief in magic was one reason that the witch hunts continued well into the 17th century.